All right, good day everyone. So today I'll be giving you guys tips on how to solve questions under atomic physics. Okay, all you have to know under atomic physics is some formulas like E is equal to HF. This formula was established by a scientist called Max Planck, and the second one is E is equal to mc squared, which was established by Albert Einstein, and E is equal to EV, which was established by Robert Albert Millikan, and E is equal to half mv squared, which is kinetic energy of electron. So all you have to know here is that anytime you are given a question in UTME, you just have to make use of the concept of conservation of energy, in which you have to equate one energy to another. Okay, maybe you say E is equal to E, and you can use HF is equal to mc squared, depending on the parameters given in the question. So the parameters given in the question will determine the energy that you are going to equate to the other. Okay, now E is energy, H is Planck's constant, which has that value, and F is frequency, which is most times always equals to V over lambda, and M is equal to mass of the particle. And if they are talking about electron in the question, you make use of the mass of electron, which is 9.11 times 10 raised to power minus 31 kilogram, and E, which is charge on an electron, is equal to 1.6 times 10 raised to power minus 19 coulomb, and big V is stopping potential, or sometimes they call it potential difference in the question. Small v is velocity of the particle, and sometimes it could be equals to the speed of light, which is equal to 3 times 10 raised to power 8 meter per second. Now let's consider this question, UTME 2008 question 45. The question says, if electron accelerated from rest through a potential difference of 10 kilovolts, what is the wavelength of the associated electron? So if you look at the question, they are talking about electron. Automatically the mass of electron will be 9.11 times 10 raised to power minus 31 kilogram. So, and you can see from the question that we've been given potential difference, and I'm looking for wavelength. So the first thing I want to do is I want to calculate the velocity of the electron. So how do we go about that? We recall all our formula, which is E is equal to half mv squared, E is equal to HF, E is equal to EV, and E is equal to mc squared. So I will equate E to be equals to E. The first E is half mv squared. The second one is HF. The third one is EV, and the fourth one is mc squared. So I'll first equate half mv squared to EV. If I do that and make my V the subject of formula, I'm going to have that formula there, which is small v is equal to square root of 2EV over m. So if I substitute all my parameters, I'm going to have my velocity to be 5.93 times 10 raised to power 7. Okay, so I'll now equate another E to be equals to E. So far I'm looking for my wavelength. So I will equate HF to be equals to mc squared. So if I make my lambda the subject of formula, I'm going to have H over mc. But you see there is a particular bracket there, that is H over lambda is equal to mc. That equation is called de Broglie equation. Okay, sometimes it could be equals to H over lambda is equal to momentum, because we all know that momentum is equal to mc. Okay, so if I substitute my parameters, okay, I'm going to have my wavelength to be equals to 1.22 times 10 raised to power minus 11 meters. So that's the answer to that question. Okay, I can see that this aspect is quite technical. So in my next video, I'm going to solve more questions on this so that we can understand the concept behind it. Thank you very much. I remain Ajadi Abiodun, PKA Ajadio.